How you doing, guys, and welcome to episode 1 of 2MChem. Thanks for tuning in. In the first video, I asked you to send in some of the questions you might need answered, and well, I had an overwhelming response. Well, not really. I had 2 legends write in asking about a question, so they're going to get featured on the channel today. Just before we get into that, if you've got a question you want answered, please write something in the description below or drop me a line at Twitter. Let me know what your question is. Also, if this video helps you in any way, please drop a like on the video. Also, subscribe for more episodes of 2MChem and all the other videos that I put up on my channel. So the first question comes from a girl called Ellie, and she writes, could we compare electrolytic and voltaic cells? And then I also had someone else write in with the name of Lachlan, who asked if we could do a video about the Electrochemical Series. So we're going to focus on the Electrochemical Series in the first episode of 2MChem, and then if you've got suggestions, make sure you let me know in the comments below. But now, let's get into the video. Okay, so 2MChem episode 1, using the Electrochemical Series. Make sure you've got your data book for this one because we're going to refer to the Electrochemical Series in it. So here is the Electrochemical Series. We've got our strong reductants, which are on the top right hand side, and our strong oxidants, which are on the bottom left hand side. And there's a continuum of strength between those two things. The reductants, well, they want to undergo oxidation and go from right to left, and the oxidants, they want to undergo reduction and go from left to right. So we get this setup which I call a Z. The top right-hand species will undergo oxidation, loss of electrons. The bottom left-hand species will undergo reduction, which is a gain of electrons. So we get this positive gradient between the oxidant and the reductant. Now, electrons will always flow down the table in the electrochemical series. So we have the thing that's losing the electrons at the top, which if it's a galvanic cell or voltaic cell will be the anode, and the positive electrode, the cathode, being down the bottom. So here's an example where we have zinc metal and it's placed into a solution of copper 2 nitrate, and we need to work out what the reaction will be. So we need to go to the electrochemical series and write in all of the possible species that could take part in the reaction. So we have zinc 2+, we have copper 2+ ions, so I've identified those 3 reactions. Now then we write them out according to the electrochemical series and identify the strongest oxidant and strongest reductant. The electrons will flow from the strongest oxidant to the strongest reductant, so that will be the zinc to the copper 2+ ions. So we can write an overall equation balancing for the electrons. If we have a voltaic cell, we again do the same process. We identify the 2 reactions in the electrochemical series. So here we have an iron and iron electrode, and here we have a copper solution and copper electrodes. So again, we set up our Z with our anode undergoing oxidation and our cathode undergoing reduction, and the electrons will go from the negative electrode to the positive electrode. So the electrons will flow down the table. So the iron will be oxidized, Fe will form Fe2+, and the copper 2 ions, well, they will be reduced to form copper solid. Hopefully that helps. I think I just got in under 2 minutes. It was pretty quick. Let me know what you think below. Do I need to reduce the number of examples and slow it down? Please send me some feedback. Let me know. If the video has helped you at all, please make sure you drop a like on it, subscribe for more, and I'll see you next time.